An inverse function is a new function that reverses the original, swapping every input and output pair. If a function is f of x, written like this, then the inverse is written inverse of f, like this. Now, let's go over this problem. Here we have f of x equals 2x minus 4. We wrote the function out in a diagram. We start off with our input x, and we multiply by 2 to get 2x. And we subtract 4 to get 2x minus 4. And this becomes our output. When we have an inverse function, we swap the inputs and outputs. So instead of y here, we'll start with x. So now let's reverse it. The last thing we did was subtract by 4, so now we're going to add by 4 instead. So it becomes x plus 4. Because we multiplied by 2, now we had to divide by 2. And we get x plus 4 divided by 2. So the inverse of f of x is x plus 4 divided by 2. As you can see, we have an important note on the side, which says that the inverse of this function is not equal to the reciprocal. This -1 here does not mean that we're dividing. It means that's just how we write an inverse. So we know that the inverse in this case is going to be x plus 4 divided by 2. And just so we clarify the difference, f of x divided by -1 would be 1 over 2x minus 4. So as you can see, these two values are not the same. Because the inverse of a function is a function that reverses the original, swapping the input-output pair, it has a unique property in that the compositions of each other will result in x. What does this mean? It means that f of g of x will equal x, and g of f of x will also equal x. So it kind of cancels out. Now, let's go through an example. In this case, f of x and g of x are inverses. So let's test out this property. So we'll start with f of g of x. As you can see, g of x here is 5x plus 40. So we're looking for f of 5x plus 40. And here we have f of x. So for every x, we need to plug in 5x plus 40. Let's do that. 1/5 times 5x plus 40 minus 8. That equals 1/5 times 5, which is x, plus 40 divided by 5, which is 8. So x plus 8 minus 8, which is equal to x. Now let's do the other one. Let's do g of f of x. The f of x we know is 1/5 x minus 8. So we're looking for g of 1/5 x 8, which means we're plugging in 1/5 x minus 8 for every x right there. Let's do 5 times x, which can be 1/5 x minus 8 plus 40. This gives us 5 times 1/5 x, which is x. 5 times -8, which is -40. And then we have plus 40, which is equal to x. I showed you both versions just so you know that you can use either order, but you only need to check one to check whether two functions are inverses. Now, let's do another practice problem. So here, we're trying to find out whether f of x and g of x are inverses. So like I mentioned previously, we can either do f of g of x or g of f of x. Doesn't matter, we can just choose one. In this case, why don't we do f of g of x? So we're looking for f of -2 divided by x plus 1. So in this case, we plug in this whole thing for the x right there. This will give us -2 divided by -2x plus 1 minus 1. And as you can see, we have a fraction in the denominator, so we can kind of flip that over. to get -2 times x plus 1 divided by -2 for this fraction, and then we can get -1. Continuing simplifying, the -2's can cancel out, so we get x plus 1 minus 1 equals x. Because the composition of these two is x, we know that these are inverses. Yes. F of x and g of x are inverses. Now that we know how to check whether two functions are inverses, we're going to be going over how to find the inverse of a function. Our first step is to replace f of x with y. If it's already written with x's and y's only, then we can skip this step. Next, we switch all the x's and y's. Third, we solve for y. And lastly, we replace y with the inverse of f. We have h of x here being 15 minus 3x, and we're looking for the inverse of h. Our first step is to make h of x equal to y, so we have y equals 15 minus 3x. Our second step is to swap the x's and y's, so we make this x equals 15 minus 3y. Now, we solve for y, so we can subtract 15 from both sides to get x minus 15 equals -3y. Divide both sides by -3 to isolate y, and we get y equals x minus 15 divided by -3. Now, our last step is to replace y with the inverse of h. So h first is x minus 15 divided by -3. Now, to check our answer, we can find h of h first, which we know should equal x, or this composition. Why don't we just check this one for fun? So this is going to be h of x minus 15 divided by -3, which is equal to 15 minus 3 times x minus 15 by -3. 15. The -3's cancel out. So this becomes positive x minus 15, which means this equals x. So we know that we found our inverse correctly. Now we have a of x is equal to the square root of x plus 5, all divided by 3. Our first step is to make a of x equal to y. So let's do that now. And now we swap the x's and y's. We get equals square root of y plus 5 divided by 3. Now, we're going to want to solve for y. So let's multiply this over to get 3x equals the square root of y plus 5. Now, to get y out, we have to square both sides. So let's do that. And we get 9x squared equals y plus 5. And then we're going to subtract both sides by 5 to get y equals 9x squared minus 5. Now, our last step is to replace y with the inverse. Get inverse of a is equal to 9x squared minus 5. Like last time, to check our work, we can either do this composition or this composition. Since we did this first composition last time, let's do this one this time. So this will be composition of a of x, which is 5 divided by 3, which gives us 9 plus 5, 3 squared minus 5, which is equal to 9 times top becomes x plus 5. And the bottom becomes 3 squared, which is 9, and minus 5. So these cancel out, giving us x plus 5 minus 5, which equals x. So we know we solved for our inverse correctly. We've reached our final challenge problem. Pause and comment the answer down below before I solve it. Now, let's get started. We have f of x is equal to x plus 6 divided by 2x minus 5. For first question, we're looking for the inverse. Now, let's get started. I'm going to write it here for spacing reasons. So, our first step is to make f of x equal to y. So let's do y equals x plus 6 divided by 2x minus 5. Now, let's swap. We get x equals y plus 6 divided by 2y minus 5. We're gonna multiply this out to get x times 2y minus 5 equals y plus 6. Multiplying out, we get 2xy minus 5x equals y plus 6. Move this y to the left and move the negative 5x to the right, and we get 2xy minus y equals 5x plus 6. Let's isolate this y. We go do y, 2x minus 1 equals 5x plus 6. So we get y equals 5x plus 6 divided by 2x minus 1. Now, our last step is to make it the inverse. So it's going to be the inverse of f is equal to 5x plus 6 divided by 2x minus 1. So our answer is going to be 5x 6 divided by 2x minus 1. Now, our second question is f of the inverse of x, and we're looking for that answer. If you guys remember, this composition is going to result in x. But let's say you don't remember and you want to check. We can do this as well. So we already found the inverse, so we can find for question number 2, we can do f of 5x plus 6 divided by 2x minus 1. Solve that. We have 5x divided by minus 1 plus 6 divided by 2 times 5x divided by x minus 5. Oh, sorry, minus 1. Minus 5. Means we can do this by multiplying 6 by 2x minus 1 and making this all a fraction. So we'll do 5x 6 divided by 2x plus 6 times 2 divided by 2. We move it all onto the same fraction. Do the same thing for here. Do 2 times 5x 6 for 2x. We'll do the same thing. 5 times 2x minus. We're just looking for the common denominator. Results in by the top, so we'll get 5x plus 6 plus 6 times 2x minus, all divided by 1. Then we'll have the bottom, so we have 2 times 5x 6 minus 5 times all over 2x. As you can see, both of these have the same denominator, so we just cancel it out. And we simplify this. We get 5x plus 6 times 2x, that's 5x plus 12x, 17x. We have 6 plus 6 times negative 1, 6 minus 6, which is 0. Bottom, we have 2 times 5x plus 6, minus 5 times 2x minus 1. You can see here, 2 times 5x is 10x, minus 10x is going to be 0x. What about the bottom? 2 times 6, 12, plus 5, because negative 5 times 6 is 1. We have 12 plus 5 gives us 17x divided by 17. So we know our answer is going to be x. As a result, we knew it was going to be x because these two are inverses. But in case you didn't know, you could do it yourself. But also this confirms that the inverse we found above was correct. So now let's do the third problem. We remember that f of negative 1, right? This inverse, this whole thing is going to be x. So we're just looking for the inverse of f at this point, right? We're looking for just this value right here, which we already know is the top value. And that's the end of this video. Thank you so much for watching.